Namaste students, welcome back to my channel. Students, in our previous video we have studied some properties of the D block element. Now in this video we'll talk about some other important properties of the D block element like colored ions and magnetic properties, complex formation, ionization enthalpy, etc. So without any delay, let's get started. First, we'll talk about ionization enthalpy. Now, what is ionization enthalpy? Ionization enthalpy is the amount of energy which is required to remove the outermost electron, most loosely bounded electron from an atom. That energy is known as ionization energy. Now, the ionization energy of the D block elements lies in between the S and the P block elements. It means the ionization enthalpy. If we talk about the first ionization enthalpy, first ionization enthalpy of D block elements. The first ionization enthalpy of D block elements are greater than that of the S block and are lesser than that of the P block. So the first ionization enthalpy of D block, are greater than S block elements, and lesser than P block elements. Means if we talk about a particular transition series, or a particular period, when we move left to right in a period, first we have S block, then D block, then P block. So when we move left to right in a period, the ionization enthalpy decreases with increase in the atomic number. Means ionization enthalpy decreases with increase in atomic number. Now, this is due to the reason that with increase in atomic number, effective nuclear charge increases, and due to the increase in the effective nuclear charge, it becomes difficult for us to remove the electron from the outermost shell. And because of this, the ionization enthalpy increases. This is the general trend. But we have a number of irregularities also. And if we talk about the difference in the first ionization enthalpy of the successive D elements, then the difference in the successive D elements ionization enthalpy are less than the difference in the successive S block and the P block elements. कहने का मतलब क्या है? अगर हम एक ट्रांजिशन सीरीज की बात कर रहे हैं, तो जो सक्सेसिव एलिमेंट्स होंगे, यानी एक के बाद एक आने वाले जो एलिमेंट्स होंगे, उनकी जो आयनाइजेशन एंथैल्पी का डिफरेंस होता है वो काफी कम होता है एज कंपेयर टू एस एंड पी ब्लॉक एलिमेंट्स की कंपैरिजन में. फॉर एग्जांपल, स्कैंडियम, टिटेनियम, वेनेडियम, क्रोमियम, these are the elements of the first transition series. Now, the first ionization enthalpy of scandium, if I write the first ionization enthalpy of scandium, it is 631. The first ionization enthalpy of titanium is 656. That of vanadium is 650. That of chromium is 653. Means while moving from titanium to vanadium, there is a difference in 6. While moving vanadium to chromium, there is a difference of only 3 kilojoule or 3 joule. So it means when we move from one element to other element in D block, the difference is very less as compared to the S and the P block elements. Now the reason behind this is, in D block elements, the coming electron is coming in n-1 D shell, that is penultimate shell. जो D ब्लॉक है, D ब्लॉक में हमारा जो कमिंग इलेक्ट्रॉन है वो कहाँ आ रहा है? पेनल्टीमेट सबशेल में. नाउ दिस इलेक्ट्रॉन, ये जो इलेक्ट्रॉन है, दिस इलेक्ट्रॉन शील्ड्स द आउटर NS इलेक्ट्रॉन फ्रॉम द न्यूक्लियर चार्ज. So the increase in the nuclear charge and the shielding effect of the d orbital, shielding effect of the d subshell, they counter each other. They counter each other. जो न्यूक्लियर चार्ज बढ़ रहा है और जो डी इलेक्ट्रॉन का आपका शील्डिंग इफेक्ट बढ़ रहा है, ये एक दूसरे को क्या करते हैं, अपोज करते हैं. एंड ड्यू टू दिस अपोजिशन देयर इज अ वेरी लिटिल बिट वेरिएशन इन द आयनाइजेशन एंथैल्पी. There is a very little bit ionization in the very little bit variation in the ionization enthalpy. But if we talk about S and P block element, in S and P block element, the coming electron will enter in the outermost shell only. So there is no role of shielding because the electron is coming in the outermost shell. But here the electron is coming in the penultimate shell. Now what is penultimate shell? A shell which is present before the valence shell. That is the penultimate shell. It means if 4s is the valence shell, 3d will be the penultimate shell. तो यहाँ इलेक्ट्रॉन penultimate shell में आ रहा है which shields the outermost electron. That's why there is a opposition between the shielding effect of d electron and the increased nuclear charge, and due to this opposition there is a very little variation in the ionization enthalpy, but we didn't get this opposition in the S and the P block elements. Therefore there is a very large difference in the successive ionization enthalpies of the elements of a same series. Now if we talk about the first ionization enthalpy of zinc, cadmium and mercury, if we talk about the first ionization enthalpy of zinc, cadmium and mercury. Now they have very high first ionization enthalpy. They have very high first ionization enthalpy. Why they have very high first ionization enthalpy? Because of electronic configuration. Because of fully filled electronic configuration. जो आपके जिंक, कैडमियम और मरकरी हैं तीनों सीरीज में, उनकी आयनाइजेशन एंथैल्पी बहुत ज्यादा होती है ड्यू टू देयर स्टेबल इलेक्ट्रॉनिक कॉन्फ़िगरेशन. नाउ we are saying that as we move left to right in a period, what happen? Ionization enthalpy increases. Ionization enthalpy increases. But if we talk about the second ionization enthalpy, the second ionization enthalpy of chromium, the second ionization enthalpy of chromium is greater than that of the manganese, and the second ionization enthalpy of copper is greater than that of the zinc. Now what is the reason behind this? We know that the electronic configuration of chromium is 3d5 4s1. As soon as chromium releases one electron, it acquires stable configuration of 3d5, and here it is 3d5 4s2. So when one electron is removed from manganese, the configuration becomes 3d5 4s1, and here the configuration becomes 3d5. So because of more stable configuration, the chromium require more energy to release the second electron. So the second ionization enthalpy of chromium is much greater than that of the manganese, and for the same reason, the second ionization enthalpy of copper is greater than that of the zinc. If we talk about the third ionization enthalpy, third ionization enthalpy of manganese. Third ionization enthalpy of manganese is unexpectedly high. The third ionization enthalpy of manganese is unexpectedly high, and the reason is again electronic configuration. Because manganese original configuration is 3d5 4s2. First ionization enthalpy, the configuration becomes 3d5 4s1. The configuration is 3d5. Now the third ionization enthalpy means, for the third ionization enthalpy we have to remove the electron from 3d5, which is the most stable configuration, and because of this reason the third ionization enthalpy of manganese, is unexpectedly high. But if we talk about the third ionization enthalpy of iron, If we talk about the third ionization enthalpy of iron, third ionization enthalpy of iron is very less. Third ionization enthalpy of iron is very less because after removing one electron from the iron, in third ionization enthalpy, after removing the electron from the iron species, we get 3d5 configuration, which is most stable configuration. And in case of nickel, copper and zinc, in case of nickel, copper and zinc, the third ionization enthalpy is very high. The third ionization enthalpy is very high, and this shows the maximum oxidation of these elements is +2. This shows that why these elements shows their oxidation state +2 in most of their compound. Because of very high third ionization enthalpy, ये elements majority किस form में present रहते हैं? In the form of +2 oxidation state. Now, the first ionization enthalpy of 5D, the first ionization enthalpy of 5D series, the first ionization enthalpy of 5D series is higher than that of the 3D and the 4D transition series, higher than that of the 3D and 4D transition series. This is due to the reason that in FD transition series there is an involvement of F orbitals. There is involvement of F orbital. So 5D in the first ionization enthalpy, the first ionization enthalpy of 5D elements, the first ionization enthalpy of 5D elements is higher than that of the 3D and the 4D element because of the involvement of F elements, F electrons, F subshell. Because of very poor shielding effect of F subshell, F electrons, what happened? The increased nuclear charge effect dominates, as a result of which ionization enthalpy increases. Because of this, ionization enthalpy increases. So, if we talk about general, so the variations in the ionization enthalpy in D block is due to their electronic configuration. The reason is electronic configuration, whether it is unexpectedly high, whether it is low, whether most of the compounds we get in +2 oxidation state. All the reason behind this is the electronic configuration of that particular element. Next, we will talk about the catalytic activities or the catalytic properties of the transition metals. So most of the transition metals and their compounds shows catalytic properties. For example, vanadium pentoxide V2O5 is used in the contact process. V2O5 is used in the contact process for the manufacture of H2SO4, or iron is used in the Haber's process. Iron is used in the Haber's process, or nickel is used in the hydrogenation of oil to fat, or cobalt in the form of cobalt thorium is used in the synthesis of petrol, So many of the transition metals and their compounds shows catalytic properties. Now the reason behind this is these transition elements have unpaired electrons in the d orbitals. These transition elements have unpaired electrons in d orbitals, and due to the presence of unpaired electron in the d orbital, they have ability to regain and emit the energy. They have the ability to regain or to absorb and emit radiations. And because of this reason, because of the presence of unpaired electron in the d orbital, they behave as a catalyst. They behave as a catalyst. Some of the transition metals, they form a complex with one of the reagent. And due to the formation of that complex, the activation energy for that reaction becomes lower, and this is the role of the catalyst. That's why they behave as a catalyst. So what they did, they combined with the reagent, they combined with one of the reagent and form a complex, and because of the formation of that complex, the activation energy of the reaction lowers, as a result of which reaction occur with a greater speed, and when that complex react with other reagent, then they decompose to regain itself again. Means they behave like a catalyst. What is catalyst? Catalyst is a substance which do not participate in the reaction, but which enhance the speed of that particular reaction, which affects the speed of the reaction. So in the same way, they some of the elements they react with the one of the reagent and form a complex which lowers the activation energy, and that complex reacts with other reagent to form product, and these elements decompose to regain itself. Clear? ये एक रिएक्टेंट के साथ कंबाइन होकर कॉम्प्लेक्स बनाते हैं जो एक्टिवेशन एनर्जी को कम कर देता है, और वो जो कॉम्प्लेक्स है वो दूसरे रिएजेंट के साथ मिलके एक तो प्रोडक्ट देता है और दूसरा वापस किसको दे देता है? ट्रांजिशन एलिमेंट को. सो दे बिहेव एज अ catalyst. For example, SO2 reacts with O2 to form SO3 in the presence of V2O5. So this V2O5 first reacts with SO2 to form V2O4 plus SO3. Clear? And then this V2O4 reacts with O2 to form V2O5. So first it reacts with one of the reagent to form a complex, and then this complex reacts with other reagent to regain itself. So in this way they behave as a catalyst, and in some cases they provide a larger surface area for the adsorption of the reactant. Greater the extent of adsorption, faster is the rate of the reaction, according to the adsorption theory. We know that, and because of this reason, the most common example is if we want to burn a log of wood, and if we want to burn small pieces of wood, then small pieces of wood will burn fast due to an increased surface area. So in some cases, transition metal atoms provides an increased surface area, which results in the maximum adsorption of the reactant, and due to the adsorption of the reactant, the rate of the reaction becomes faster. So this is the catalytic properties of the D block elements. Now we'll talk about the colored, means why the most of the compounds of the D block elements are colorful in nature in the solid state as well as in the aqueous state. Unlike that of the S and the P block elements. The ions of the transition elements are colored in the solid state as well as in the aqueous solution. We have studied that S and P block ions are colored in their aqueous solution but not in their solid state. But unlike S and P block elements, the transition element ions are colorful in their solid state as well as in the aqueous solution. Now the reason behind this is DD transition. The reason behind this is DD transition. Now what is DD transition? In 11th class, we have studied about the degenerate orbitals. Means orbital of the same subshell are known as degenerate orbitals. Degenerate orbitals are the orbitals of a same subshell which have same energy in the ground state. In D subshell, we know that we have 5 orbitals. In D subshell, we have how many orbitals? We have 5 orbitals, and these 5 orbitals have same energy in the ground state. Therefore, these 5 orbitals are known as degenerate orbitals. Degenerate orbitals. As soon as an anion or a ligand, means as soon as other atom approaches these orbital, as soon as the other element approaches these orbital, what happen? These orbitals splits into two different orbitals. These orbitals split into two different orbitals. These orbitals split into two different orbitals like this. And in this case, the degeneracy break. जैसे कोई भी एटम ट्रांजिशन एलिमेंट्स को अप्रोच करता है, वैसे ही ट्रांजिशन एलिमेंट्स की डीजेनरेसी क्या हो जाती है? ब्रेक. जो आपके 5d ऑर्बिटल्स होते हैं, दे गेट ब्रेक इनटू टू डिफरेंट सेट ऑफ ऑर्बिटल्स, एंड दीज टू डिफरेंट सेट ऑफ ऑर्बिटल्स हैव डिफरेंट एनर्जी, and the electron, one or more electron from the lower energy level jump to the higher energy level. Clear? One or two electron from the lower energy level jump to higher energy level. Now the energy which is required to jump, which is required to move the electron from lower energy level to higher energy level is very less, and it comes in the visible region. That energy comes in the visible region. So the element of the transition group, the transition element absorb that amount of energy, emit the electron or jump the electron from lower energy level to high energy level, and rest of the energy is emitted by the transition element, and the emitted energy radiation is observed in the form of the color. Means जो अमाउंट ऑफ एनर्जी रिक्वायर्ड होती है ट्रांजिशन एलिमेंट्स को, दैट अमाउंट ऑफ एनर्जी ट्रांजिशन एलिमेंट अब्सॉर्ब करता है, इलेक्ट्रॉन को हायर एनर्जी लेवल में जंप कराता है, और जिस अमाउंट ऑफ एनर्जी को रिलीज करता है, एमिट करता है, वो हमें किस फॉर्म में शो होता है? इन द फॉर्म ऑफ कलर. इन द फॉर्म ऑफ कलर. Now, if we talk about S and P block, so in S and P block there is no half-filled elements. एस और पी ब्लॉक की अगर हम बात करें तो वहां पे हमारे पास हाफ फिल्ड और पार्शियली फिल्ड डी एलिमेंट्स नहीं है. एज अ रिजल्ट ऑफ विच देयर इज नो डी ट्रांजिशन नहीं होता, एंड द ट्रांजिशन फ्रॉम एस ब्लॉक टू पी ब्लॉक और एस ब्लॉक से पी ब्लॉक में जो ट्रांजिशन है, इट रिक्वायर्स वेरी हाई एनर्जी दैट नॉट कम्स अंडर द विजिबल रीजन. दैट्स व्हाई दे आर कलरलेस. क्लियर? व्हाई the d ions are colorful? Because here dd transition is possible. For dd transition, very less amount of energy is required, which is under the visible region. But for ss transition or pp transition, sp transition, a very large amount of energy is required, which is not come under the visible region. That's why these ions are colorful and the ions of s and p block are colorless. Now, the color which is absorbed by the element and the color which is emitted, these colors are known as complementary colors. And the complementary color idea we get to know by the Munson color wheel. Munson color wheel. Now, the Munson color wheel is very busy. The Munson color wheel is very busy. Instead of very, it's very busy. बहुत busy है. Vero, V-R-O. Busy, B-G-Y. Complementary color of violet is yellow. Complementary color of red is green. And complementary color of orange is blue. Orange is blue. Now, why the copper ions are blue in color? Why the copper ions and the compound of copper ions are blue in color? Because they absorb red color wavelength. And the complementary color is greenish blue. The complementary color is greenish blue. That's why they appears greenish blue or blue. So this is the Munsell color wheel, and you can learn Munsell color wheel by two words: vero busy. Clear? So why the transition elements show colored ions? Due to dd transition. What is dd transition? The electron from the lower energy orbital jumps to higher energy level. The energy required for this jumping is very less, which comes under visible region. that amount of energy is absorbed by the element and the remaining energy is emitted in the form of the radiation, and that radiation is observed in the form of the color. And the color which is emitted and the color which is absorbed, that are known as complementary colors, and we get the idea of the complementary colors by Munsell color wheel, and Munsell color wheel is very busy. That is violet, yellow, red, green, orange, blue. Clear? But if we talk about Sc3 positive and Ti4 positive. If we talk about Sc3 positive and Ti4 positive, these ions are colorless. These ions are colorless. Now we are saying that transition metals are colorful, and here I am saying that these are colorless. Why these are colorless? Because if we talk about the configuration of these two, their configuration becomes D0. Means they don't have any unpaired electron in the d orbital. They have electron in the s and p orbital, and there we don't get pp or ss transition. So that's why they are colorless. Similarly, if I talk about Cu positive, Ag positive, Au positive, Zn2 positive, these are also colorless. These are also colorless. Now why these are colorless? They have d electrons, but they have d10. It means they have fully filled electrons, and fully filled electron means there is no jumping, there is no moving of electron, and if there is no moving of electron means these are colorless. These are colorless. So colored ions are due to the unpaired electrons, and the dd transition. Because of this, the transition elements are colorful. Clear? Now we will talk about the magnetic properties of the transition elements. Magnetic properties. In the solid state of 12th class, we have studied that on the basis of the magnetic nature, the substances are categorized as paramagnetic and diamagnetic substances. Paramagnetic substances are those substances which have unpaired electrons in them and they are attracted by the external magnetic field, and diamagnetic substances are those which don't have any unpaired electrons in them and they are weakly repelled by the external magnetic field. Now, due to the presence of unpaired electrons in the d orbital, most of the transition elements shows paramagnetic nature. Most of the transition element shows paramagnetic nature. Why they shows paramagnetic nature? Due to the presence of unpaired electrons in the d orbital. And the paramagnetic nature and the extent of the paramagnetic nature is calculated by a formula, that is mu equals to n under root n plus 2. Under root n plus 2, where n is the number of unpaired electrons. Means more the number of unpaired electron, greater the value of mu, that is the dipole moment. Mu is greater means the paramagnetic nature is more. For example, if I talk about Ti2 positive and Ti3 positive. Now the configuration of Ti2 positive is 3d2 and the configuration of Ti3 positive is 3d1. Here I have two unpaired electrons. So the value of mu is 2.76 Bohr magneton. Bohr magneton is the value of mu. And for this, the value of mu is 1.75 Bohr magneton. So because of the presence of unpaired electrons in the d orbital, most of the elements of the transition series, most of the elements of the d block show paramagnetic nature, and their paramagnetic nature can be calculated by using the formula mu equals to under root n plus 2, where n is the number of the unpaired electrons. But if I talk about the magnetic moment of Sc3 positive, then the magnetic moment of Sc3 positive is 0. Because in Sc3 positive, the configuration is 3d0. It means we don't have any unpaired electron. That's why its magnetic moment is 0. Similarly, if I talk about Zn2 positive, Zn2 positive is also 0 because here we have electron in d orbital but we have fully filled electron. So paramagnetic nature is due to the presence of the unpaired electron. Agar unpaired electron honge, so the substance is paramagnetic. Otherwise the substance is not paramagnetic and its mu value is 0. Uski mu value kya hogi aapki 0. So this is about the magnetic properties of the d block elements. Complex formation. Most of the elements of D block form complex compounds. Most of the elements of D block form complex compounds. For example, FeCN6 3 negative, FeCN6 4 negative, NiCN4 2 negative, and many more. But S and P block elements, they don't form complex compounds. Now, why D block element forms complex compounds? Now, the reason of the D block elements to form complex compounds are, first, size. They have small size. Second, they have high charge. Now, due to these two reasons, they have high charge to size ratio. Clear? They have small size and they have high charge, and because of this they have high charge to size ratio, and they have vacant d orbitals. For the acceptance of electrons. Acceptance of electrons. So because of these three reasons, they form a number of complex compounds. And because of the absence of these reasons, the S and the P block elements not able to form the complex compounds as formed by the D block elements. So these are the various properties of the D block elements. So today we have studied many important properties of the D block elements, and I hope the concept is clear to you. And if the concept is not clear to you, please see the video again so that the concept becomes clear to you. So I'll see you in my next video with the new topics of D block elements.